All right, this is your week 14 quiz review. So you should be watching this before you take the week 14 quiz to help you on it. All right, so the first review problem that I have for you, I have an equation for a line. And this line, I'm supposed to find the slope of a line that would be perpendicular to this. So here's the line that I have. I want the slope of a line perpendicular to this one. So if this line looks like this, then I want the slope of this line. So to do that, I got to figure out the slope of this line first. So to do that, I need to get it in slope-intercept form. So I will move that 12x over to the other side so that I'm in the form y equals mx plus b. So now I know slope is always the number in front of the x when I'm in this format. So my slope is negative 12 for this line. But remember, I want the slope of a line perpendicular. In order for a line to be perpendicular, the slope would have to be an opposite reciprocal. So I simply flip it over and change the sign. So 1/12 would be the answer. All right, next problem is one where you have to graph and shade. So let's get some graph paper up here. So on this one, on this top line right here, I will do it in black. You want to cross the y-axis at -2. Remember, this is the x-axis, this is the y-axis. I want to cross at -2, and my slope is -1/3. That would mean down 1, right 3. Down 1, right 3, all the way across your board. Or you can also go up 1 and left 3 as long as one of your directions is negative. And there would be that line. Notice that this line is dotted. There is no equal to sign underneath it, so you could just use these black dots as your dotted line. If you want to put markers in between them, you could do that as well. Okay, and we're supposed to shade above that line. I may wait to do the shading until I get the other line graphed as well. However you want to do it, it doesn't really matter. This line right here is going to cross the y-axis at 3 and have a slope of 1. I'll do that one in blue. So I'm going to cross the y-axis at 3. Slope is up 1 over 1. And so I actually want a solid line for that one. So I will draw a line through that one. And there we go. All right, so I have the blue line and the black dotted line. The black dotted line said greater than, so that means I put my pencil anywhere on this black dotted line. Greater than means to go straight north or straight up, and that's the side of that line that I want to shade. This black line I could shade underneath it or above it. I want to shade above it because it says greater than, so I will lightly shade above that. And then the blue line, I will shade in a different color. Shade that one in a green. And above the blue line, or actually I want to go below the blue line because it says less than. So less than means below, so I put my pencil anywhere on this line. I go straight down, and that's the side of the blue line that I want to shade. So I will do that in a green. And now, wherever those two colors overlap is my answer. So you have to somehow show that you know where those two colors overlap at. So I'll use a brown and color in that shaded region where they both overlap at. So all the points in this shaded region, along with the points on this line, will satisfy both equations. All right, next example is an exponents problem. Get rid of our graph paper, and we want to simplify this. So to simplify this, you would first want to use the power rule on this thing right here. I have 3 sets of this, and so to shortcut that, I'm going to use the power rule and take every power in here times 3. So if I do that, I will have 3 to the 3rd, a to the -6, b to the -9. And once you've done that power rule, then your parentheses is gone. I still have the a squared and a B, and then on the bottom I have an A and a B. So now anything that has a negative exponent, you want to shove down to the denominator, keeping everything else in the same spot. So that's all I'm doing. Right now that's all the stuff that doesn't need to be moved. Oops, I forgot the cubed on my 3. 3 cubed, a squared b over ab, and now these two get shoved down to the bottom, and when you shove them down there, they have positive powers. And so now we can simplify some more. I could cancel this b with this b. I could cancel this a with one of these a's so that I only have one left on top. And now I'm left with, on the top, a 3 to the third. And I also have an a up there. And on the bottom, I have an a to the 6th and a b to the 9th. And it looks like I can cancel one more a. I can cancel that one with one of these, which would leave me with 5 of them on the bottom, a to the 5th, b to the 9th. And that is my answer. If you want to put a 27 instead of a 3 to the 3rd, that would be acceptable as well. All right, next is a scientific notation problem, and this is one that you'll want to type in on the calculator. And when you type this in, you're going to type in 4. You're going to hit the second button and the E key, which the E key, it doesn't really have an E on it. It's the comma key, and it's right above the 7. So hit second, and then the key above the 7, which is the comma key, and this little E should pop up on your screen, which means exponent, so then you type in the exponent. I want to multiply these two scientific numbers, so I hit multiplication times. Then I type in 5.2. I tell the calculator once again that I'm doing scientific notation by hitting second and then comma. The E for exponent shows up, and then I type in the exponent, which is -4. Then you're going to hit enter. All right, and here's a picture of my calculator to show you what it looked like on my calculator screen. The 4, the E, the -5 times 5.2 e to the -4. And this is the answer we got, 2.08 e -8. And so that would mean 2.08 times 10 to the -8th power. And that would be your answer. All right, next problem, you're supposed to graph this, and actually I think I may have graphed it for you on the quiz, and then you have to tell me all the characteristics of it. So if we get some graph paper up here, I'll make my y-axis, x-axis, all right, so this is a parabola, and you know that because it has an x and a squared in it. So you're going to want to shift your graph 4 places to the left and 2 places up. 4 left, 2 up. And I know this is left because this one's always the opposite of what I think. This is the number that tells me up, down. This is the number that tells me left, right, always the opposite of what you think. And if there were a negative here, it would turn it upside down to a sad face. So let's graph the vertex. Remember, your vertex is typically here on a parent function. But if I shift that left 4 and up 2, now my vertex is going to be right here. So there's my new vertex. I know it's a happy face parabola, not a sad face, so I'm going to go up 1 over 1 to get the other 2 points. And then to get 2 more points, I go right 2 up 4, left 2 up 4. And if I wanted to go again, I could go right 3 and up 9, which would get up there pretty high. So if I graph this U shape, I have something that looks like this. So what kind of questions will you be asked? You'll be asked to state the vertex and then tell me if it's a max or a min. Well, here's the vertex right here, and that is at -4 on the x-axis and 2 on the y. And this vertex is the lowest point on that graph, so it's called a minimum because of that. So there's your vertex. Also, you would want to state the axis of symmetry. And it's always a good idea to draw it in so you can actually see it. The axis of symmetry is a vertical line. And just like we named vertical lines last semester, vertical lines are named by which axis they cross and where at. So this line is crossing the x-axis at -4. So that's my axis of symmetry. All right, how about a vertical translation? What was my vertical translation for this parabola? Remember, that's the number on the end. This thing moved up 2. What kind of horizontal translation did I have? How did it move left or right? Well, even though it said +4, it moved left 4. And did I have an x-axis reflection? This is a yes or no question. No, it did not turn upside down. So vertical translation, horizontal translation, x-axis reflection, axis of symmetry, and vertex. Those are the things you need to know for the quiz. All right, next example, you are asked to multiply this, and I have given you a 2x2 box to do so. So multiplying would that be comparable to perimeter or area? Well, you take length times width on a rectangle to get area. So this would be comparable to finding the area, which means I want to set up my box like this. Kind of like a Putnam square in biology. And so I take this times this to get this. That's 24x squared. I take this times this to get this. Negative 32x. I want to take 5 times 3x. And if it's helpful to put these on the other sides, you definitely can. I would take 3x times 5 to get this box, so that's 15x. And negative 4 times 5 to get this box, that's negative 20. And now you want to remember, when you're finding area, what's inside the box is your answer. So that's going to be 24x squared minus 32x plus 15x minus 20. So notice that these two are like terms, and I'm going to end up adding those together. So a negative 32 and a positive 15 is going to mean I need to actually subtract. So that would give me how much? 15 to 25 is 10. Another 7, that'd be a negative 17x for those two. So 24x squared minus 17x minus 20 is what you get when you multiply these two together. All right, next problem is a substitution problem. And just like we've been doing these all along, you're going to want to replace the y with what y is equal to. So 2x minus 4x minus 12 is equal to 10, which means I have a negative 2x. Move that 12 over or add 12 to both sides. That gives me 22. Change my signs. Divide by 2, I get negative 11. So there's one of my answers. Now I want to take that, go back here and plug that in for the easiest x I can find. So y is equal to negative 11 plus 3. So y is going to be a negative 8. So my point of intersection, if I were to graph these two lines, would be at negative 11, negative 8. And that would be your answer. All right, next question. On this one, you were asked to factor and actually give the length times width, knowing that you know the area. So if this is the area, and I'm supposed to find length times width, and you've been given a box that looks like this. So remember, if this is the area, that means it goes inside the box. And so now I want to factor out what these two boxes have in common. So they do not both have k's, so I can't pull any k's out, but they do have something that will go into 30 and 40, and that would be 10. So if I pull a 10 out, what would I put here and here, so that when I multiply it times 10, I can get this. So 10 times a 4 and a k squared would give you a 40k squared. What times 10 will give you a negative 30? A negative 3. So now you have to write your answer in terms of length times width. And that is your answer for factoring this problem. All right, next problem is another factor problem. And on this one, I give you a box that looks like this and tell you to factor it. So remember, if this is the area, that means it goes inside the box. You're supposed to find the length and the width, which goes on the edges of the boxes. So what do the two have in common? Well, all three boxes have at least 2 p's, so I would say a p to the second power. And what number will go into 30, 21, and 12? Well, the only one I can think of would be a 3. 3 goes into all 3 of those. So now what would I put here, here, and here, so that when I multiply times 3p squared, I get this? So 3p squared times what will equal this? Well, 3 times 10. And then I would need a p to the third because I want these two powers to add up to 5. Okay, now I want, what times 3 will give me 21? That's 7. And I'll need a p to the second power so that my powers add up to 4. And then 3 times 4 will give me 12, and I do not need any more p's at all. So my answer is length times width. 10p cubed plus 7p squared plus 4, and that is my answer. Okay, and this is the last review problem we have, and this is a Pythagorean theorem problem where you're supposed to figure out the missing side. Notice you're missing one of the legs, and so for one of the legs, you got to do 6 squared plus x squared equals 12 squared. So there's your leg, 6 squared plus x squared equals 12 squared. I'm trying to get x by itself. So to get x by itself, I'm going to subtract a 6 squared from both sides. So now the x squared will equal 12 squared minus 6 squared. And if you want to get rid of a squared, you're going to need a square root. That's how you get rid of squareds. So x is going to equal, because the square and the square root cancel each other out. Over here they don't because I got this minus sign in the middle, so I'm going to work that out. That's 144 minus 36, which you can do on the calculator. And 144 minus 36 is going to be 108. So now, how can I break that 108 down? Well, you got to find something that has a nice square root that will go into 108 evenly. So 108 should be divisible by 4. Anytime the last two numbers are divisible by 4, the whole thing should be. So 108 divided by 4, you could do that on the calculator. 8, subtract, I get a 2. Bring the 8 down, I get a 7. So now it looks like 4 times 27, because let's see, I got to take 7 times... Subtract, sure enough, I get 0. So 4 times 27 is equal to 108. So I can replace this with a 4 and a 27. Only thing is, 27 breaks down. 27 breaks into 9 times 3. And so now the square root of 4 is equivalent to a plane 2. Square root of 9 is equivalent to a plane 3. Square root of 3 doesn't break into anything, so my answer is 6 square root 3. Now, there was an easier way to do that, but you had to recognize that 8 plus 1 is 9, and since 9 will go into that, it will also go into this. So 9 goes in here evenly. That was another option. Another thing I think that we don't catch is that 36 will go in here. So this is the same thing as 36 times 3. And the square root of 36 is 6. So that's the fastest way to do it if you catch it. But there's several ways to do that one. And that's all for your review. You should be ready to take your quiz.